Hello everybody, this project is on the life of a star. Now, a star begins evolution from a nebula, which is basically just a giant cloud of gas, dust, hydrogen, stuff like that, just floating out there in the middle of space. And gravity causes the nebula to break down into smaller and smaller pieces. Each of these fragments, the gas releases heat as energy, and as the temperature and pressure increase, all the fragments combine and condense into a rotating sphere of super hot gas known as a protostar. A protostar is also known as a baby star because nuclear fusion hasn't taken place yet, so therefore it's not technically a star yet. When the fusion of hydrogen begins, the heat from the fusion of hydrogen causes pressure that balances attraction and gravity together. Basically what that means is that the gravity is condensing the star so that it wants to crush it, but yet the intense heat inside the star wants to make it explode, and the two balance out to get perfect balance. And from there, fusion, go back to fusion. Fusion is when the nucleus of two atoms, they crash together, combine together, and instead of making a compound, they make a new element. For example, two hydrogen atoms coming together to form a helium atom. Now, once the main sequence star gets so long, the hydrogen fuel is going to run out sometime. So the hydrogen fuel in the core starts to get exhausted, and because of that, the core contracts and it becomes extremely hot. And the heat from a core causes the outer layers of the star to expand, and the outer layers cool as a result of the expansion, and the material from the outer layers of the star begins to escape into space. And now, helium, as a result of nuclear fusion, is now used as the fuel to generate the star's energy. And since we are talking about the mass of a star that has like 6 solar masses, instead of turning into a white dwarf, this is now a red giant. Now, the heavier and heavier elements obviously start to appear in the core because of constant fusion, And the core is going to be very, very hot because of this. And the heat from that core causes the outer layers of the star to expand to an even bigger size, creating what we call a supergiant. Now, eventually, those elements are just going to get so heavy that fusion can't take place anymore. An example of this is iron. Iron eventually forms in the core, and since there's no more energy producing fusion reactions, because of the heaviness of the elements, the iron does not release energy. Instead, the process actually consumes the energy. And because of that, the star suddenly collapses because the energy that causes the pressure that counteracts gravity is no longer produced because the element's too heavy. And this is called a supernova. The shock wave from the collapse causes outer layers of the star to explode. Now, normally what would happen after a star explodes in a supernova is that it would shrink to where the core remains so dense that only neutrons can exist, and that's called a neutron star. Now, what you see there is the actual size of a real neutron star compared to the size of Manhattan, which is, if you don't know, is where New York City is. So all the particles in there are so tight together that it makes it really small, but yet it's extremely heavy. But what happens in this case, since the star is so big, is that the core shrinks, and the core is so dense that the gravitational force causes the core to just keep shrinking. And this makes what we call a black hole. Now, a black hole has gravity so strong to the core that nothing can escape its pull. It pulls in everything, even light. And this concludes our presentation on the life of a star.
When you wish upon a star, makes no difference who you are. Anything your heart desires
This video has been authorized and approved by Chuck Norris.